Okay, so nice to meet you, everyone. Thank you for coming to this presentation. Yeah, actually, it's my first presentation in English, so yeah, that's the demo effect. So yeah, so my name is Pierrick. I'm working in Melkali as a software engineer, and I'm mainly working for all the DevOps environment around our Android project. Today, I'm going to explain how to Kotlinize your CI from Gradle tuning to Kotlin Script. So first, let me explain you what do I mean by CI and the challenge we faced when we were maintaining it. After that, I'm gonna explain 3 ways I use in order to leverage Kotlin in our CI. So first, let's see what do I mean by CI. So yeah, let's read the Wikipedia definition. So CI is continuous integration. It's a practice of merging all developers' working copies to a shared mainline several times a day. That's quite vague, but yeah, I guess we understand that all developers' changes will be merged in a shared branch. It is need to scale with the number of developers contributing to your project. Let me explain the 2 main use cases of our CI in Melkali. So first is what I call the hot path. It's a workflow running every time a change will be made in your CI. So notice it's including many jobs. I put the drawing on the right, like with the init job being the first one, and the later one depending on the init job, and like the bottom one depending on build. So for this workflow, time is critical, especially for the init and build jobs, because they are used by the other ones, and also because engineers are waiting for them. So this is the first use case. Second one is all automation, so what we could say regular task. So there are several of them we're using in Melkali. For example, UI tests are not running in all PR. Like in this one, it may happen time to time, but at least every day we will make sure that all UI tests are running and a report will be generated. That's one example. The second one is the weekly dependencies update, because like we have a tool to automatically generate, to fetch the new updates. This thing is done every week. But for example, this one is done Thursday morning, but at 8 a.m. But no one will wait for the report at 8 a.m. So it can take 10 or 20 minutes. It's not as important. But like the challenge for this regular task are that like the errors are usually fixed by the CI maintainers. So probably you, maybe, if you're attending this talk, because usually the Android developers are busy working on feature development. And so in my experience, they are lacking time or knowledge to fix these regular tasks. So in order to understand how a CI works, we need to understand roughly how Docker is used in order to build our project. So Docker is allowing us to build a Docker image, which is defining the environment that will be used in our CI. So in this example, we are defining a Docker file for a Java 11 installation in order to build a Java project, for example. As you can see, we can use commands to add new software. Imagine Docker as a zip containing the files needed for the CI execution. So as you can see, for example, after using like a base image, like the Ubuntu one, we install the Java 11 in the /JDK folder. And so that will be the difference between the Ubuntu one and the Java image. I added the JDK files. So yeah. This Docker file is used as the definition of the image. We will push with the name java-image in a Docker repository. So notice the name is followed by a version called tag by Docker. In this case, we are pushing the version 11.0 of this image. This version can after be used in our CI configuration. Here is provided a circle CI example. but the same logic can be used with any modern CI provider. So now that we understand Docker, we can define a way to consider our CI execution into 3 layers in order to better understand how it can be configured. So first is a Docker environment. That was previously defined in the Docker file. We have to define a Docker image, but there's nothing more we can do at this step. That's why I defined this layer as the one defining the static foundation of our CI. If we want to run some logic, for example, to install something that's not already available in our Docker image, we can run some logic in the bash environment that is running on our CI machine. The first command is usually a git clone of your project in order to build it. The last layer is usually the Gradle execution itself. Gradle being a complex piece of software and being able to run as many tasks as we want in one execution, we will assume that each CI job will try to use Gradle only once. So now that we understand what's a CI, let's take a look at the specific situation I found when I started maintaining this Android project in Melkali. So our CI was including some Ruby because initially we were trying to share some resources with the iOS automation, and iOS is usually using Fastlane, and so that's why we were using Ruby. Python was also introduced for some scripting alongside Ruby, and JavaScript was used by another team for some reasons. So why not continue with historical integration? So first of all, each language requires integration like linting or dependency management in order to be used efficiently. Most integration were not maintained because it could not be maintained by Android engineers by lack of knowledge. So why Kotlin? Because as you guess, we choose Kotlin as a replacement. So Kotlin is not an extra language to learn. Like, I'm sure most of you here are Android engineers and you're using Kotlin every day, so it's not something new. And also, it does not require an extra tech stack to maintain because our Android project is probably already supporting Kotlin, and so we could try to leverage this existing integration for our automation as well. Yeah, so we are now ready to start introducing some Kotlin. Let's discover how. So, here is the most common situation in an Android project. Like, usually you will use the CI provider default images. That's easy to use. You just configure it, and that's all. But it has some cons, I believe. Like, for example, breaking changes can happen at any time because there's no fixed version. Usually, you will not update this configuration. And also, like with this tool we integrated, it's like a black box. We have no control on what is provided. And also, because we have no control, we cannot make sure that it includes the tooling that we want to use, like our favorite tooling. But if we start to use homemade Docker images, we can have following advantage, like semantic versioning. Like every time you will try to change the image, it will be in a pull request, and so it can be reviewed by your peer, and you can also detect the breaking changes at that time. Also, because you are creating these images, you can start integrating some extra tooling. So for example, in the image, you can see like the circle CI image is including Java and Python, but the homemade image can include Java, Python, Ruby, and Kotlin. That's up to you. So yeah, to create these custom Docker images, we spent time creating a new project called Toolbox. Please remember this name because it will be reused later to reference this project. So this new project allows us to host our first Kotlin automation code. The idea was to slowly starting migrating part of Ruby or Python by introducing Kotlin inside the script. This was achieved by creating a Kotlin application callable from existing script. So, as explained before, we need to push a Docker image to a Docker repository. Our custom Docker images are pushed to Docker Hub, which is a common place when creating Docker images. This is later used in our Android CI project configuration. And yeah, also an extra tip is like Docker Hub private usage. Like it can be used privately for the fixed price of $25 per month. This is pretty cheap, considering we are not paying storage or network ingress. So this is like a pretty cheap way to start using this strategy. So let's review some of the libraries used in our Android application that can be used to write nice automation code. So the first one is Clicked, as you can see. Like this, helping to write command line helpers, allowing to consume app parameters. So you can see the app.jar can take argument 1, 2, also like if you give the key, you can give a value. All these things are easily usable with Clicked. The second one is Kotlin Process. That's basically allowing you to run external applications, like a script or any command line. And because this is a Kotlin project, we can also use other dependencies, like Google Cloud libraries, to integrate with Google Cloud, for example, or Slack API client to send message to your in-house Slack workspace. Or yeah, even GitHub, you can comment the pull request that initially triggers the CI build. So yeah, that's also up to your imagination. So let's take a look at how we can easily define our custom Android image reusing the CI provider default one. So as you can see, I'm using the CI image, circle CI image, because with the from statement. And our only addition is to add the Kotlin application we mentioned earlier. It's achieved by building this Kotlin application in the toolbox CI that we later use with the defined Docker file to publish our custom Docker image. So yeah, as you can see, the Kotlin code is built, and with the jar and the Docker file, we can create an image that we push to the Docker repository. As another example, to run non-Android jobs, we can use a standard Java image plus the extra homemade tooling I mentioned earlier. So, with this first step, we could already remove some Python and Ruby script from our Android project. Let's consider the second way to introduce even more Kotlin in our CI layers. So I said, we have these custom Docker images, and they are great. But we were facing some limitation by relying more and more on them. The first one was that each update was quite a slow process, because every time you update the toolbox project, you had to recreate a Docker image and to change the Android CI configuration. This is a slow feedback loop. Also, it is not possible to provide quick and easy local tooling. Like features like code generation or like tooling that could be used in CI or local are not easily possible. So can we provide automation directly from our Android Gradle project? So to solve this question, let's think about how Gradle is working internally. Every time you run a Gradle task, you need to provide its name to run it. In this example, I'm calling the test debug task from the app module. Notice many other tasks are also mentioned by their name when running their test debug task. We can identify each task individually, but it's not enough to define a task logic. More than a name, the logic that is done when running needs also to be defined. This is achieved via a class which is associated with each task name. With the help command, we can see that the task test debug unit test is using the process application manifest class defined in the Android Gradle plugin. And the task test debug unit test is defined by the Android unit test class. So now that we understand that the task is defined by a class, we can now introduce the JavaExec, which will be the root of our second iteration. It's running a Java application as a standalone program. Kotlin being able to create a Java application, Kotlin code can be run from a Gradle task by providing the good parameters. So we need a Gradle module in order to define such task. So let's consider a script module to host our JavaExec tasks. But how to create one? Just declare a new task of type JavaExec and a name. In our case, it's called run app. After, you can run this task by giving the script module name plus the task name from the command line or Android Studio on bottom and right. Previous code was just an example. Let's take a look at a real script module as we can find in our Android project. So first, let's define the dependency to the Kotlin plugin on the top. Next, the dependencies that will be used in our Kotlin code. Sorry. Defining a JavaExec task can be complicated, so I created an helper method as the following one can be helpful. Here we can see an example. So what could have been done in a Gradle plugin is just simple Gradle instruction in the script build.gradle.kts file. So for example, we can use a native task like copy. But we can also use our own Java-powered application located in the script source main. So as I said before, basically you need two things to define a JavaExec task. A name, here is a strip available version, and the second one is a main class, as you can see here, com, git, pigrease, blah, blah. So yeah, with Kotlin, it's possible to write complex business logic code as easy as a scripting language like Python. This code can be testable in script source test with the same setup as your Android unit test. We can also use any Java or Kotlin dependency as we wish, including the custom logic we previously wrote in our toolbox repository. That's actually one benefit of having invested in a separate toolbox project, because we are already having Kotlin-powered automation code. And so it's easy to push this code in a private Maven repository and start consuming it in our new script module. So yeah, as you can see, we are using both toolbox from the Docker hub, but also from the Maven repository. It is also possible to use the script task in the root project, allowing to further customize an already existing task. In this case, I'm running custom task before and after the refresh version task, which is the one handling the auto update of our dependencies that I mentioned earlier. You can see it in the execution actually. First backup version, after refresh version, and after compiling Kotlin code, we are using the JavaExec task. So this approach can also work even if you have to deal with a large Gradle project. In order to do so, you can turn your scripts folder as a composite build. In this case, it will become an independent script Gradle project without any Android dependency. So yeah. Be careful to open it with IntelliJ because Android Studio is limited on composite build support. For an example is like, it's not easy to run tests in a composite build from Android Studio. But yeah, being an independent project, and so a small Gradle project, you can even run tasks in isolation by specifying a custom directory as root project when using Gradle instead of the current directory. That's what you can see on bottom and left. Like I call Gradle, but I use a script folder as the Gradle project only. And I'm using the strip available version defined before. So, what are we missing here? Like, let's summarize what we have. Like, we have Docker-powered Kotlin applications available in our CI. It can be shared across several projects, Android projects, and it's also shared via Maven artifacts. And we can use Kotlin in our Gradle project, like our Android Gradle project. It has a fast feedback loop and no overhead, our Android project being Kotlin first. But I had to maintain a special tool I will describe here, which was the Firebase Test Lab integration. It was written in Python originally, but this was becoming a pain considering the growing numbers of features of this script. Among feature requests, I had like the need to filter test on demand. So instead of running all tests, just test like a specific screen, for example. Also, like the Google Firebase Test Lab reports were not so great. So I was asked to provide custom reporting and also to maintain the easy retry feature that is available for this script. To understand this feature, please look at the right, like where you have the CI flow where we are creating the application first and after running the Python script. And if the Python script had to be rerun, it could be run directly from the Circle CI website. But yeah, as you can see, this was definitely gradually moving from a not so simple script to a real project. So this was a perfect opportunity to give a try to Kotlin Script because it just requires a Kotlin installation, so no Gradle dependency. It's way easier to run. And also, it can fetch Maven dependencies. This is out of the box, which is a really powerful feature compared to Python or Ruby, where simple scripts are easy to write, but if you need any dependency, you need to deal with complex dependency management with pip or bundler, and also virtual environment tools. Just notice that it's working well with Maven Central or other public Maven repositories, but if you need authentication, this may become a pain to use. Kotlin Script is allowing us to create a new way to consume our toolbox Maven dependencies. We can write testable plus reusable code there. Yes. And we can consume like the toolbox Maven dependencies in a bash like Kotlin Script, where only high-level instructions are implemented in the Android repository. Easy to use, as we said. And it's also CI friendly because it's actually pre-installed on GitHub Action runners. This is a link to see when and how it was introduced. So to run such Kotlin script, we can create our own Docker image by extending a standard Java image. After installing Kotlin, and if required, the extra homemade tooling we were already adding in the first step. So yeah, so in the case of GitHub Actions, like you do not need this file because it's by default. But for Circle CI, yeah, I had to define this custom Docker file to run Kotlin script, for example. control. So, as a conclusion, do you remember the CI layers I previously mentioned? We finally succeed to introduce Kotlin in all presenting layers. From like the Docker layer, where we are providing the Kotlin application, in the Bash environment, where we can just run Kotlin Script. And if you are using Gradle, you can use the script module that was defined in the second step. So yeah, thank you a lot for attending this presentation. Arigatou gozaimasu.